So we've talked about the reference parameter, modifier, reference parameters, and output parameters. You define them with ref and out. What those are is the data is not passed in by value, but passed in by address, which means that the method can modify that data and the changes will affect the data that was passed in by the client code, by the calling code. Otherwise, if I pass an int into a method and it's just a value parameter, one defined without a special keyword, then that value gets copied in, and sure, the method can then change the value of that variable, but it doesn't change the original data. If you wanted to change the original data, you pass it in as a ref or an out. Ref just means that the thing might modify it. Out means that it absolutely must modify it or else the code will not compile. And you've seen the out modifier whenever you use try parse. The way try parse works is that if it succeeds, it returns a true. If it fails, it returns a false. And if it succeeds, you check the value of the parameter that was passed in as an out parameter. So that method was actually able to modify it. What we didn't get to is parameter arrays. What are parameter arrays? Well, we've seen like console.out.writeLine, where, not writeLine, yeah, writeLine, where if you have c.o. write, whatever, you can pass in one thing, right? I'm going to pass in, a piece of data I want to display, hi. Or I could pass in, a couple of things, right? Several things I want to print out, and so I'm going to print out some string and another string. Well, this is pretty miraculous. We've seen method overloading, which is when you have two methods with the same name but different parameter lists. But .write could accept one parameter, two parameters, three parameters, 20, 30 parameters. It's not just limited to a certain. It would be real tedious to go and do method overloading to support that many variations of it. So instead, you provide what's known as a parameter array. And the parameters that it's not an array that it's not a parameter that accepts an array. Not like this, not like you have an array, that you've declared, and then you pass that into your function, right? That's not a parameter array. It's a parameter that is an array, but it's not a parameter array. A parameter array is an array that accepts a variable number of parameters, like that. And stores those in an array. So a parameter array is a parameter that accepts a variable number of arguments and stores those in an array. So a parameter array, it's a local array. It's declared within the method header in the parameter list using the keyword params, not ref, not out, called params. And you use it when you don't know how many arguments of the same type could be sent to that method. Now my question is how does writeLine accept strings, integers, and doubles if they all have to be of the same type? That's some dark voodoo that I don't know. So no additional parameters are allowed after the params keyword, right? Because, if you're accepting some data into your function, and it's got that, how does it know how many you're going to be passing in? And then how does it know that this piece of data was supposed to pass in a different parameter, right? How would it know what the end of the array was and where the new parameter list was supposed to pick up? So, can't do that. The parameter array has to be the last thing in the parameter list. And you can only have, for the same reason, one params keyword, one parameter array. Because how would it know how to divvy up the data? So here's their example. They have something called display strings. And it creates an array of strings called people. we don't pass in an array of strings. We pass in one string. We pass in 3 strings. We can pass in an array of strings. That works as well, but we don't have to. And we could pass in no strings at all, and it would work just as well. We may as well play with that, but since they did strings, let's do something a little bit different, like ints. It'll work the same way. What lecture are we on, gang? V, perhaps? I think it's V. Let's go with V. So let's create a method called sum that will take varying numbers of ints. We're not going to specify that it can only take 1 and then create an overload that could create 2 and create an overload that could create 3. We've done that example already. But if we were going to do that, you'd have to create a version of it for every number of parameters you want to pass in, you know, from 1 up to 100 or whatever. We're not going to create 100 overloads. We're going to write one method that can accept varying amounts of data. Since I'm going to be calling it within main, I know that I'm going to be, since main is static and it's in the same class, I better make it static. Since I want it to return a value, we can make it return an int. It's going to be called sum. Params int. I'm just going to call it PA for parameter array. And get rid of that semicolon there. I don't know what I was thinking there. Guess I was thinking C++ where you define function prototypes. All right. Not all code paths return a value. Well, that's very true. Why don't we declare a variable called total, or sum with a lowercase s or something like that, and then return it, but then go in and add the code that we actually need to calculate that sum, right? So int sum equals 0, or, you know, total. I like total. I don't like the variable in here to be too close to that name. Just kind of an old fear of having multiple identifiers with the same name. Doesn't work in Python. Why not avoid it in C++? Alrighty, so int, or C#, total, return total. Yeah, great. That'll work. Doesn't do anything, doesn't calculate our values, but we can prove that it would compile, right? Int x equals sum. I really don't like methods with capital letters, even though that's a C# standard. I'm just old and set in my ways. We're going to add 10 and 20. Excuse me, 29. All right. Int y is equal to the sum of 10, 20, 30, 40. Int z is equal to the sum of nothing, which ought to be 0. Now, right now, x, y, and z are all going to be 0 because they're all returning that value. But we can make a for loop that'll rip through this array, adding each value to the total. What's the easiest kind of for loop to write is the for each loop, because you don't have to keep track of an index counter. For each, parentheses, int value in the parameter array, total plus equals that value. And I guess I better go and add my read line down at the bottom. I always forget to do that. And I haven't printed out x, y, and z. I'm just going to prove that it works by setting a breakpoint, running it to this point, and then checking the value of x, y, and z with the debugger. You could add a statement to print out the values of x, y, and z if you wanted to. So I'm going to run it. It rips down here. It got to my breakpoint, so I know that x, y, and z have been set. X is 30. 10 plus 20 is in fact 30. Y is 100. 10, 20, 30, 40 is 100. And z is 0 as expected. So isn't that kind of cool, writing a function that can accept varying pieces of variable amounts of data? I think that is really cool. It can also accept an array of integers. You could just go ahead and create your data in advance and pass it in there. Int IA equals, let's pass in 1, 2, and 3. And then int A equals the sum of that array. So if you're going to write a function that accepts an array, and it's not going to do anything to it, it's not going to modify it or anything like that, you might consider just making it a params parameter, so that you could pass in an array like that, sure, but you could also pass in the data discretely, right, like that. I hadn't really thought about that, but it makes sense to me. You're going to write something that's going to accept a one-dimensional array of data, and all it's going to do is sum it up or do something with those values, but not modify them. That's a key. Then you can pass it in as a parameter array. If it does need to modify the data, then absolutely you cannot pass it in as a parameter array, because this is not something that you can modify and have it change the result. For example, if you changed PA subscript 0 to 25, is that supposed to magically change that value to 25, and the computer's going to think that a 10 is a 25 from here on out? Nah, not going to work. We could do the same thing with an array of strings, or, you know, an array of objects. I'm not sure what that would look like, but I mean, you know, you just be passing them in as additional things here. If you were trying to do some polymorphic application, then you would, that's jumping way ahead of where we are, and unfortunately we're not going to get there. So overloading, we know what that is. When you write multiple versions of the method that has the same method name. The method has to have the same name, but it has to have a different parameter list, because if it has the same name and parameter list, then what's the point, right? If you write two methods that only differ by their return type, it wouldn't know which one it was supposed to call. So it definitely has to have different parameter lists. And that's called its, quote, signature. In C++, we called it its prototype, I think. But anyways, methods are overloaded correctly when they have the same identifier but different parameter lists. Overload resolution is how it figures out which one to tie it to. Right? If you have two overloaded methods, at runtime, it's got to figure out which one to call. Maybe it's not even at runtime. Maybe it's the at compile time. I know that in Java it's done at runtime via a mechanism called dynamic binding. So overload resolution used by C# to determine which method gets executed if it could execute multiple overloaded methods. For example, you could write a method that accepted both an int and a double. Now a double can accept an int, right? So when it was going to be called, which one would it invoke? All right, so if you write, you know, void foo and it takes an int, and then you write another version of foo that takes a double. I'm not even adding a body there. Apparently that's bad though. Oh, it's because I'm still in debug mode? I don't see my red stop to indicate that I need to stop. All right. Apparently I've lost my little...
Well, it's telling you to continue, so I don't think it's...
I see that, but I don't see my red stopper. All right, anyways. Oh, fine then. I'll just close you here. All right. All right. So anyways.
I think it's still running.
It did it again. Debug. Stop debugging. I've lost my little red stop sign there. So anyways, if I call foo with an int, we know which one it's going to call. I mean with a double, right? We know that it's going to call this version. And I didn't make these static, so it's giving me an error here. If I come back and add the word static, then I'm good to go. Right. So when it calls, or when we hit that, we know that it's going to invoke this one because a double is not appropriate to pass into an int. However, if we pass in an int, it could conceivably go into this double. And it would if this was commented out. It would still compile. You know, an int can be upgraded into a double safely, so the compiler will do it, lets it happen, so that works. But it could be that we want a method that handles an int much more precisely than it would as if it was converted into a double. There has to be some reason why we would write, you know, the same method with two different parameter types. And so resolution says that this one is going to be passed to this one, but this one is going to be passed to this one, even though conceivably it could get passed to that one as well. Also, the idea is that we might have an optional parameter with a default value, right? Int x, int y equals 2, right? Don't put the semicolon there, right? And so this one could conceivably call that one. And it would if this one was commented out. Resolution would say, oh, you have an int? Well, I need to pick one that has an int as a first parameter. And oh, looky here, we're going to have a second parameter that defaults to the value of 2. But if we have both of them available, it will decide that this one is the better fit. I hope that's actually the case. I'm going to walk through it with the debugger, even though I don't have my next button available here. Where did you go? All right, well, anyways, I'm going to set my breakpoint here. I know which one the double's going to call, so I'm not going to step into that. I'm more curious about this one. You know, I could just add a print statement, and that would resolve it very quickly as to which one of these it's going to go in. So it steps down here. I need to step into it. Oh, there's my little goodies. All righty. There's my little goodies, and I want to step into it to find out which method it's invoking. So I'm going to click the step into thing. And it did, in fact, step into the most appropriate one, which is the one with only one int. If you don't want it to call that one, you better just like delete that one and let it call this one, right? Or make that a non-optional parameter, right? To make it a non-optional parameter, you would take, you know, that out. A non-optional parameter is a mandatory parameter, right? Mandatory parameter has no default value. An optional parameter does. Right. So this is an optional parameter, meaning that you could pass it in, right? We could pass in, yeah, I know. You can't. Press the red stop. You could pass in two values there, and then y would accept the second argument that was passed in, but if you don't, then it just would invoke that one. Kind of really okay if you don't type all those in because they're not doing anything right. But if you want to have the example, that's fine. I'm going to flip back to the PowerPoint for a moment, though. So some methods require passed-in information called arguments. They could also be called actual parameters. No, that's not the term for it. There's formal, and then there's something else. Anyways, you write methods to make programs easier to understand. Wait. All of a sudden, we're at the summary. How'd we get to the summary so fast? great. We hit the end of the chapter really lickety-split, but it's not what I intended. I guess we have 2 PowerPoints going. All right. So the rules are the betterness rules. Just like data can be converted to a type based on the implicit type conversion rules, like an int can be converted into a double, but a double cannot be converted into an int without casting. Then the betterness rules are it tries to match the data type most precisely. So that one matches this one most precisely, and then it tries to match the parameter list most precisely. This one can accept 2 parameters, but this one can only accept 1, and since we're only giving 1, that's the most precise match. When you use the IDE to create programs, Visual Studio's Intellisense feature provides information about the methods that you are using. Like what? All right, yeah. So like if you're converting something, well, we've been seeing this all semester, right? And you're starting to type, it's called Intellisense. It pops up this stuff. Makes it easier for you to pick which method that you want and stuff like that. Tells you what it returns and all sorts of things like that. Like if we have console dot, you know, whatever, we want to write something out. We never did, but say that we wanted to. Now I have too many of these guys up here. All right, so console dot, right? We have a whole bunch of options here, and if I leave it there, then it'll tell me what, you know, what it returns. Readline returns a string. It doesn't accept any arguments. Some of these things will accept multiple arguments. Let's do console.out.write line parentheses. Oh boy, there's 18 different versions of it. I can step up and down through the versions. That one accepts a, you know, Boolean variable. That one accepts a character, a buffer of characters, a decimal, a double, a float, an int, a long, an object, a string, a uint, a u-value, and then an array of objects. Right there, a parameter array, an array of objects. That's how it handles the fact that you might be printing one thing, but you know in here you might be printing a whole bunch. Don't type this because I'm going to delete it, right? It's accepting these as an array of objects, and then it's going to do some magic to figure out what kind of object it is. It's going to check to see what type it is and figure out that it's an int or something and handle it appropriately as it's writing it out. Avoiding ambiguous methods. Ambiguous methods are when you have a situation in which the compiler cannot determine which method to use. So if you overload the methods, they have identical names and identical parameter lists, then they're ambiguous methods. Like if you tell somebody to go to the red house with the blue car parked in front of it, and there happens to be 2 red houses and with blue cars, then you wouldn't know which one to go to. An optional parameter, we've talked about them. When you give it a default value so that an argument does not have to be provided for it. Only value parameters can be given default values. Reference parameters, you have to actually pass a reference in, right? So you can't give an optional default value for a reference. All right, I inflicted a quiz on y'all over chapters 7, 8, and 9. Last second, you're going, I don't want to do another quiz. But let's go take a look at it. A hint for this quiz is that every true-false question is true. I hate writing quizzes with false statements in it. So chapter 7, 8, and 9, feel free to go ahead and open it while we're looking at this. I'm going to preview it. You could even take it right now while we're looking at it. All right. But I'm going to call upon Denise and Simon, who are in here. How many methods can a class contain? Only one? None at all? Or any number of? How many methods can you add to a class?
I'm pretty sure our program right now has more than one.
Yeah, our class already has like 7 or 8 methods. So I'm going to go with any number. Which of the following is a good reason for creating methods? Both of these are true. Well, we'll see about that. Methods are easily reusable. Yeah, supposedly. Grouping blocks of code into methods can make the code easier to understand and revise. Yeah, that's definitely true. I'm liking those. So I'm just going to go with that one. This one should go at the bottom, but the randomizer isn't smart enough to make that one go at the bottom. So a method must include which of the following? And I'll give you a hint here. You can leave off the access modifier. When we were doing our code here, we didn't say that foo was public or private. We could, right? But we left that off. It's optional to provide the access modifier. Now, it can be very important which one you pick, but it's optional. So, you must include an access modifier? No, this just said that. It's not. How about a return statement if the return type is not void? Yeah, that's absolutely true. Otherwise, what is it returning? And then it has to have a return type. Now, the book would say that's true, but then when you write a constructor, it doesn't have a return type. But in general, that's a super special exception that proves the rule. Every method you write will have a return type, even if it's just void. So, if a method does not have a declared accessibility, such as public, private, or protected, then is it illegal? Is it void? Is it non-static? What is the default access level?
Private.
Private, yeah.
You just told us that in the previous question.
Yeah, I did give you that. All right, so if you read the hints carefully. All right, so a field that is public can be accessed by the calling code outside the class, while a private one cannot. Well, yeah, that's why you make it public, so that the code, that created the object can change it. Well, guess what the next one is? It's asking about private. A field that is private can only be accessed by methods within the same class. That is true. And then the third type, actually it seems like the book had even more than that, but the common third type is protected, which means that it can only be accessed by methods within the same class or classes that inherit from it. And we didn't get to inheritance really. Did we do inheritance? Did we manage to squeeze that in one of our prior lectures?
No.
Do y'all want to come in on Thursday, even though it's past the end of the
Something like
semester?
Cat and Tiger,
No, we did not.
but I don't know if we really got into inheritance.
Okay, yeah.
That was implements, but that wasn't inheritance.
Oh, we did implement but not inherit. Yeah, okay, so implementation is a very specific form of inheritance. If y'all want to come in Thursday, we can do a lecture on that, but I'm not going to make it mandatory.
I like to have that one.
You'd like to do that one?
Yep.
All righty. Okay. Optional lecture. Extra credit if you do it. All right. If you use the keyword static, you indicate that the method cannot accept parameters. Well, if we were looking at here, we had static methods that accepted parameters, so that's pretty goofy. Don't like that answer. Can only be called once? Now that's ludicrous. Cannot be copied? I don't even know what that would mean. And is called without an object reference. That is correct. That is correct.
Yes.
Right. If you need to specify how it is called, you use the class reference instead. So, all of these static methods, we could have called them using the class name. We could have said, all right, program.sum, right, and program.foo. Now, why would you do that? What if you had a static method in another class that you wanted to call? Right, you wrote another class called data, and it had some static methods or fields, and you'd say data dot. I'm going to undo those and make things look a little bit more complicated. A method's return type specifies what? Now this is real easy, so I want one of y'all to tell me. I mean, y'all can tell me the hard ones too, but well, a method's return type does not specify its accessibility. That's public or private. Its return type does not specify the parameters. It certainly doesn't specify its scope. Oh, so working from the bottom up. I wonder why that one has a period and the rest of them don't. That was my mistake. Go with that. When you use a method, you do not need to know how it operates. I have no idea how console.out.writeLine works. It's magic. That's called implementation hiding. I like that one. When I copy questions from the book, which I sometimes do and sometimes don't, they come up with wacky answers. What is scope management? It sounds great. It's not the answer. When you write the method declaration that can receive a parameter, you need to include all the following items. These are mandatory. Do you have to have the type of the parameter? Yep, in this language you do, because we're not using Python. Do you have to provide a default initial value?
No.
Nah. So that's definitely the exception. But let's check the third one anyways. And a local name for the parameter. And that's true. You have to provide the parameter with a name. Oh, good grief. Both of the above and they're underneath it? I guess I better modify question 11, huh? A parameter can be passed in by value or by reference. Yeah, that's true. Just depends on how you write it. If we wrote a function that accepted a something by value, right? Static void test, these are all accepting them by value, but we could, make a reference int x, and then it would actually be able to change the value of x. So, yes, you can write one that accepts a value, or you can write one that accepts a reference. So both of the so-called above. Alrighty. And then we're jumping ahead to chapter 8. To create a parameter that a method can modify and have those changes passed back to the calling code, you can use the refer out keywords. Is that true or false? Uh-oh. Well, I think that's true. Just because of my hint, but even so, right? That we just said that's why you use the ref keyword. So a mandatory parameter. Oh, and here's my hint. 2 answers are correct. The last one is correct, by the way. So a mandatory programmer requires that argument be sent in. Is it preceded by the keyword man? Have we ever even seen that keyword before?
Oh, by the way, our answers are different order.
Yeah, and they're in a different order. Okay.
So the last one,
yeah.
We don't know if the last one's correct.
I might just click the thing that says don't randomize the order, and then all those would show up correctly. All right. Does a parameter have local scope? Does a parameter have an initial default value? No, because then it wouldn't be mandatory. So that's definitely wrong. I'm thinking that this one's wrong too because I've never seen the man keyword, and if we went in here and tried to type it, no, man keyword, so we know that's not true either. So local scope. And what does that mean? That just means that this variable x, if we called this, xxxx, right? That variable can't be used in another method, right? It's local only between these two braces. So it is a local variable. All parameter variables are local to that method. So local scope is definitely correct. Which type of parameter receives the address of the variable passed in? And you can add a parenthetical comment. Which type of parameter receives the address rather than the value? A void parameter? Now I like that answer because what would a void parameter be? Void means nothing. That's definitely not it. a reference parameter, an output parameter, or a value parameter? If two of them are correct, which would you want to go for?
Reference output.
Yeah. Well, that's a funny little square there. And overloaded is, Denise, I want you to pick one of these for me.
Okay.
A method with the same identifier or a method with the same parameter list.
Okay.
So when we overloaded the foo method,
Mm-hmm.
we gave it what? The same
Same.
parameter list or the same identifier?
Same identifier.
Yep, yep, yep. And an object is a what? Okay, I love these silly words. Insinuation of a class. I'm going to insinuate that. An institution. Now that's closer, but it's actually the instantiation of the class. It creates an instance of it. How come all of these have a little square in front of them? All right. Is this true or false, gang? An object is created with the new keyword.
Yes.
Well, how else would you create it? Now, weirdly, in C++, you can create objects without the new keyword. But not in this language. Not in Java either. Right, because we know how to create an object. If you had an object called dog, right? Don't type this. Or dog d equals new dog, right? That's how you create a dog object, which is an instance of the dog class. But we don't have that, so go away. So, most fields, most instance variables are created public or private. And when we say most, this is in common programming practice. We want to keep our data encapsulated. And to keep our data encapsulated, are we going to make our data public or private? I think I heard somebody say the answer. If you made your data public, would it be encapsulated? Encapsulated means protected. Nah, nah. And so this reference can be referenced in static methods or non-static methods. Now that one may be a little bit of a head scratcher. What is a static method? A static method is one that doesn't exist inside any object. Since it doesn't exist inside any object, it doesn't have a this reference. It applies to the class itself or all objects of that type, even if you don't have any objects created whatsoever. So you can use this only inside non-static methods. Because static methods don't have an object that they're referring to. They have a class that they are referring to. All right. Maybe I gave too many hints. A constructor is a method that has no return type. That's true. The same name as the class. Yep. And an optional parameter list. Yep. And it's invoked by the new keyword. Absolutely true. All righty. I'm going to submit it. I have one unanswered question. Did I skip one? It says see the right sidebar, and I don't have a right sidebar. But I think we covered them all.
The right
Ah, here we
sidebar
go.
already at the
I
top.
forgot to answer this one. Yeah, the static keyword means that it's called without an object reference. Very true. Instead, you can call it with the class name. Alrighty, now I think I can submit it. Alright, if y'all want to come back Thursday for one more lecture over inheritance, that'd be awesome. Alright, let's stop our lecture here. I'm pretty happy. We have actually done a pretty good covering of Chapter 7, 8, and 9, even though I made just one quiz to cover them all. I think we've actually hit these concepts several times in a row already. So hopefully they're burned in by now. And no homework. Be working on your projects.